Good morning, my dear students. How are you all? Are you all okay? Okay. So in the last class, we have seen about the galvanic cell. I have given you two examples, that is zinc copper cell and copper silver cell. So if you are given the cell name, are you able to write the anode and cathode in that? For example, zinc copper cell. In zinc copper cell, which is anode and which is cathode. So zinc is the anode and copper is the cathode. Likewise, copper silver cell, which is the anode, copper is the anode and silver is the cathode. If magnesium copper cell, magnesium is the anode and copper is the cathode. Clear? So which one is the highly reactive element, that is taken as the anode, and low reactive element rod, that is taken as the cathode. Clear? So today we can see about the electrolytic cell. Electrolytic cell. So from the word itself we can understand it is by the presence of electrolyte. What do you mean by electrolytes? What is electrolyte? Electrolytes are the substances which pass electricity through it. That is electrodes. Clear? Or electrolytes. Electrolytes, for example, acid, base, alkali and salt are used as electrolytes. For example, copper sulfate you can take it as the electrolyte. Silver nitrate you can take it as electrolytes. So electrolytes are substances which conduct electricity in molten state or in aqueous solution. What is molten state? Aqueous solution means mixed with water. And mainly acids, bases and salts of in aqueous or molten state is used as electrolytes. For electrolysis, an electrolyte is essential, and at the same time two electrodes are essential. So which are the electrodes? Anode and cathode are the two electrodes. Positive charge electrode and negative charged electrodes. Clear? So electrodes also necessary for electrolysis. Then electrolyte is a substance which conduct electricity in molten state or in aqueous solution. Clear? Then electrolysis. What is electrolysis? Electrolysis. What is electrolysis? You know that by passing electricity through water or acidified water, so we can separate the hydrogen and oxygen in the separate cells or separate anode and cathode. Clear? Likewise, we can see some of the electrolytic cells. See, this is the arrangement of an electrolytic cell. Here you can see the electrolyte. Any electrolyte, it is not given the name. Then there is cathode and anode. See the charge in cathode and anode. In galvanic cell we have seen the anode is negative and cathode is positive. But here this is the electrolytic cell. In this it is just opposite, that is anode is positive and cathode is negative. But oxidation takes place in anode and reduction takes place in cathode. Then these are the two electrodes, anode and cathode. Cathode are the two electrodes. Then this is the electrolyte which conduct electricity or which pass electricity through it. Then it is connected with the wire and voltmeter. Here two electrodes are connected with the wire, and at the same time we can see the voltmeter also. So this is the arrangement of electrolytic cell. That is, electrolyte is essential, two electrodes are essential, then at the same time voltmeter and wire also essential, and here battery also essential for this one. So this is the arrangement of electrolytic cell. In which cell is selected, accordingly there is difference in the anode and cathode. So anode, I told you already, in electrolytic cell anode has the positive charge and cathode has the negative charge. But in galvanic cell it is just opposite. Anode is negative and cathode is positive. But here the oxidation is in the anode and reduction is in the cathode.